Everyone thinks NVIDIA's lock on AI comes from the GPU. It doesn't. The real moat is something most people never think about, the network that wires those GPUs together. In a modern AI system, no single chip matters. What matters is whether 10,000 of them can act like one. And the way you connect them is, quietly, the most powerful lock-in the entire industry. Lose access to it, and even the best chip in the world is just an island. In 2026, the rest of the world finally united to break it. This is the fight to connect AI, and it might decide the whole race. First, the thing nobody explains. Every AI cluster actually has two completely different networks. The first is scale-up. Inside a single rack, a few dozen GPUs are wired together so tightly they behave like one enormous chip, sharing memory at terabytes per second. The second is scale-out. That connects rack to rack across the whole data center, linking thousands or even millions of GPUs into one cluster. Scale-up is short, brutally fast, and expensive. Scale-out is longer, a little slower per link, and built for massive scale. Get either one wrong, and your 10,000 GPU supercomputer grinds down to the speed of its slowest link. And here's the key. Both of these networks are dominated today by one company, NVIDIA. It owns the inside of the rack with a technology called NVLink, and it has a powerful grip on the network between racks too. To understand the fight, you have to understand both. Pressure 1. NVLink, the moat nobody talks about. Inside NVIDIA's flagship rack, 72 GPUs are bonded together by NVLink into a single giant accelerator. Each GPU pushes about 1.8 terabytes per second to its neighbors. The next generation, built for the Rubin chips arriving late in 2026, doubles that to around 3.6 terabytes per second. To put that in perspective, that is more than 10 times the speed of the PCIe slots in a normal server. This is what lets thousands of GPUs train one model as if they were a single brain. At the center sit NVS switch chips, wiring every GPU to every other one at full speed, so any processor can reach any other's memory almost as if it were local. That tight coupling is what makes a whole rack behave like one machine instead of 72 separate ones. But here is the catch, and it's the whole point. NVLink is completely proprietary. Only NVIDIA makes it. If you buy NVIDIA GPUs, you are automatically locked into NVIDIA's network, NVIDIA's switches, and NVIDIA's rack. You can't simply mix in another company's chips. The GPU gets the headlines. But NVLink is the cage. It is the single most underrated reason NVIDIA is so hard to compete with. Pressure 2. The scale-out crack. Connecting rack to rack, NVIDIA pushed its own technology, InfiniBand, for years. It was fast, but it was proprietary and expensive, and it locked you in all over again. So the rest of the industry made a bet. Take plain old Ethernet, the technology that already runs the entire internet, and make it good enough for AI. In 2025, a giant alliance called the Ultra Ethernet Consortium shipped its first specification, giving Ethernet the low latency and lossless behavior that AI training demands. For years, the knock on Ethernet was that it dropped packets under heavy load, and a single drop packet can stall an entire training run. Ultra Ethernet was built to fix exactly that, and it's working. In 2026, Ethernet is overtaking InfiniBand inside AI data centers. The appeal is obvious. Ethernet is open. Dozens of companies build the chips, so prices fall and nobody is trapped. Broadcom, Arista, and the hyperscalers are all in. Even NVIDIA itself now sells an Ethernet option of its own. This is the first place NVIDIA's networking grip actually started to slip. But scale-out was always the easier battle. The real prize, the one NVIDIA guards most fiercely, is the network inside the rack. Pressure 3. The revolt reaches inside the rack. Breaking NVLink is much harder because scale-up is where NVIDIA's moat is deepest. So in 2024, almost every other major player in computing joined forces. AMD, Intel, Broadcom, Google, Microsoft, Amazon, and more formed the UALink consortium, building an open rival to NVLink. The spec is serious. UALink can connect up to 1,024 accelerators in a single pod, even more than NVLink, at 200 gigabits per lane. It also lets accelerators share memory across the pod, the same trick that makes NVLink so powerful, but without locking you to a single vendor. The promise is the same one Ethernet made for scale-out, now aimed at the heart of NVIDIA's fortress, an open standard so you can mix AMD chips, Intel chips, and custom silicon in one rack, with switches from Broadcom and Astera Labs instead of from NVIDIA. The first UALink hardware is expected to land in late 2026. And notice who is not in the consortium? NVIDIA, because UALink exists for exactly one reason: to give the industry an exit from NVLink. For the hyperscalers spending tens of billions on AI, even a small crack in that lock-in is worth fighting for. The cage finally has a door. Pressure 4, and this is the clever part. NVIDIA is not standing still. Its answer is a move called NVLink Fusion. Instead of keeping NVLink totally closed, NVIDIA now lets hyperscalers plug their own custom chips into an NVLink rack. Building your own AI accelerator? Fine. You can still wire it together using NVIDIA's network. It is a brilliant defensive judo move. If the industry wants openness, NVIDIA offers just enough of it to keep everyone inside the NVIDIA fabric. So who actually wins this war? Step back, and the answer is the same one we keep finding. It's the company that makes the switches. Whether the world standardizes on NVLink, UALink, or Ethernet, somebody has to build the switch, chips, and the high-speed links that move the data. And one company sells into all three camps at once. Broadcom, it builds the Ethernet switches, it is helping build the UALink switches, and it makes the underlying connectivity for almost everyone. Astera Labs sits right beside it. Think about that position. Broadcom doesn't have to bet on which standard wins, because it already sells the picks and shovels to all of them. Its networking and custom silicon business has quietly become one of the biggest winners of the entire AI build-out. So here's the verdict. We measure the AI race in GPUs, but a GPU on its own is almost useless. What you are really buying is a network of them, and the network is where the power actually sits. NVIDIA's greatest moat was never just the chip. It was NVLink, the proprietary fabric that quietly locks you into its entire world. And in 2026, for the first time, that moat is under real assault from two directions at once. Ultra Ethernet is already winning the battle between the racks, and UALink is coming for the battle inside the rack, the place NVIDIA guards most fiercely. NVIDIA's counter, NVLink Fusion, shows it knows exactly how valuable that network is. But here's the punchline. No matter who wins the standards war, the same kind of company cashes in, the one that makes the switch silicon and the high-speed links underneath all of it. Broadcom and a handful of others get paid whether AI runs on NVIDIA's network or the open one. That is the pattern of this entire build-out. The loudest fight is over the standard, but the steadiest money sits one layer down in the silicon that every standard depends on. The compute gets the headlines, but the connections decide who is free, who is locked in, and who quietly profits from all of it. If you want to understand the AI race the way the industry actually sees it, not the hype, but the choke points and the lock-ins that really decide it, then this channel is for you. SerDes was the signal, co-packaged optics was the medium, and the network is the battlefield where it all comes together. There is a whole layer here that almost nobody is covering, so subscribe and stay with it, because the AI race isn't won in the compute, it's won in the connections.